step ahead a little bit from a lot of the fundamentals that we've been looking at in the school to say, okay, assuming the fundamentals are in place, what are the new interesting challenges from a research perspective in this area? There are many, right? And so I'm just taking a very specific perspective of how does artificial intelligence and hybrid cloud research come together, right? These are two overused words in the industry, very buzzwordy, but there's actually a lot of meat in there, right? And I hopefully at the end of this talk, you will go away with some clarity on that. So yeah, so maybe a lot of you have, how many of you have some familiarity with AI or machine learning techniques here? Oh, wow, okay, amazing, that's great. And of course, now you're experts in hybrid cloud. So I think this will be an easy talk for you. So let me move ahead, right? And I have this long title here with cognitive enterprise in there, right? It's a term that we sort of formulated at IBM as a lot of us, and of course our CEO has worked with our clients over the last several years. So these are large clients, right, such as SBI, or the other day I was mentioning bestseller Veromoda, right, or in the US Walmart, or MetLife. And to understand where they are, these are old companies, these are global companies. Where are they today, and where are they trying to go in their business operating model? And what we have realized is that there's a common theme, right? And I'll talk a bit about it to help you understand what is this cognitive enterprise and how does that then translate to why are they looking at hybrid cloud and how do these research problems come up? Okay, so this is a very, very high level. So, you're a big business, let's say you're an SBI. The world is changing. Payment banks are coming up, right? You have Paytm and all of this. Everything's going digital. If SBI does not adapt, it's going to be in big trouble, okay? So that's one simple example, right? So there's a lot of continuous change. Let's look at some of the drivers of this change. Customer expectations for the businesses are extremely rapidly evolving compared to, say, 20 years ago, when a lot of these big companies were formed. People want to engage with companies through social media. I want to do fund transfer through WhatsApp. Why should I have to go to the bank? Why should I even have to install an app? I already have WhatsApp. I just want to say, or of course, digital is a basic thing, right? I want to do digital payments. I don't want to carry cash, for instance. I want multi-channel engagement. So I should be able to walk into the Veromoda, look at some clothes. I ran out of time, but maybe a day later I log on. I should be able to see what did I see, continue my shopping experience, and then it gets delivered somewhere. And if I want, I may engage through any channel with the enterprise, and the experience should be seamless. Right? I want a cognitive experience. What does that mean? I want to be able to just speak to the phone as if I'm talking to a person, and I should get whatever services I want. I should be able to take a picture of the shirt Mudit is wearing and buy something similar. But the big businesses that exist today don't necessarily support this. But the new businesses are starting there, right? If you look at an Amazon or a Flipkart or some of the new unicorns that are out there, they're starting here. So how do these older businesses rapidly change while running the ship, right? That's a big challenge. The other big driver is the regulatory landscape that is also happening, that companies have to comply with. Privacy is a big one. India itself is putting in place a privacy GDPR from Europe, and there are many such coming up across the world. And they just suddenly land, and then now you have to comply with it next day, right? That's a huge change. GDPR, for instance, requires that, if Amith says, Facebook, you got to delete all the data that you have of mine for the last 10 years. Now it's got to go find in all its databases and logs wherever my data is, and delete it. It may not even have those systems to be able to recall that, right? How do you put in place all of that? Similarly, regulations around digital business regulations, and these regulations are different for different geographies. Privacy means differently in Europe versus India. Now, if you're a company that operates in so many different geographies, how are you going to comply with all of those laws and keep your systems up to date? Technology disruptions, I think this is one we are very familiar with. AI comes in, and now all these new companies are using it, and you're not using it, you're going to not be competitive. Cloud comes in, you're not using it, you're not going to be competitive. Blockchain comes in, 5G comes in, and these are coming in at such a rapid pace, right? Every year there's something new happening. Are you going to run your business, or are you going to keep reading about these and training your people to now incorporate these into your systems? It's a huge disruption. And then new competitive business models, right, which is sort of a consequence of all of these. There are these digital models. For example, now there are companies that sell gold digitally. So then what happens to all the jewelers? Right? It's much easier for me to just buy gold having breakfast at home rather than go somewhere and try to find it. There's platform business models, right? If you look at, let's say, Uber, it's a platform. It's not just selling you a product. Of course, you buy a product, but it creates a platform where others come in. Then on that platform, it can create Uber Eats. It can do advertising. Same for Ola, right? And that's just one example. So the business models are changing from I sell one thing to I create a platform. I'm selling one thing, but then the platform gets created where I'm getting so many other capabilities on, right? That creates a gravity. So as you can see, lots of changes in the environment that businesses operate in. That drives a lot of things, right? That's where the need to become a cognitive enterprise, the way we call it, comes in, right? And simply stated, how at least I think about it is, a cognitive enterprise is able to predict these changes rapidly and is able to adapt with agility, right? They may not need 6 months of planning and thinking and all of that to decide what to do, right? You should be able to move fast and do it at very low cost, right? Of course, you can hire 100 people who now know AI and blockchain and all of this. People who have worked in industry and joined new jobs, it takes 3 months to even understand what your company does. And then you have to implement something that advances the state. It's just not feasible. How do you do that at low cost and high agility while maintaining security and compliance with all of these changing regulations? So that's a cognitive enterprise, because it's not just a fixed enterprise. It is sensing its environment just like human. That's why the term cognitive. So our senior leaders in IBM, they've sort of come up with this layered view of what's inside a cognitive enterprise. How does it work? It's a bit involved and a bit abstract, but I'll just walk you through it because I think it's a good background, right? So let's start at the top. The first thing is the culture of agile innovation. A lot of these companies, again, I'll take the example of SBI, not to beat on them, but they had a way of working, right? You go to the branch and so on, right? Changing that is not easy. They have to go through transformation. And it's about the culture, how people are used to working. So that involves culture, that involves skills, IT skills, business process skills, operational skills, and how you work. So the cognitive enterprise has agility in all of these elements. It is powered by an ecosystem of these business platforms. I gave you some examples, right? At a high level, these could be industry platforms, right? So for example, we in the blockchain area, IBM and Maersk had this industry platform for shipment tracking for global logistics, right? That brings the industry together onto a platform. Or it could be transaction platforms like payment platforms, right? That enable transactions and then creates gravity. They are activated by these cognitive enabled enterprise workflows, right? So if you look at the things that are happening in a big business, right? You can categorize them in these 3 areas. Decision making. What should we do next? That's, of course, constantly CEOs, CFOs, VPs, MDs, managers, everybody's making decisions. If you don't make the right decision, you're going to be in trouble. So how do you make the right decision in this changing landscape when you don't have the time to learn everything? Then front office processes. So that's mean where you're engaging with the customer. So if you have a mobile phone, subscription with Airtel, right? So you have a touch point with Airtel. So everything Airtel has to do to keep you happy are all the front office processes around billing, accounts, customer support, all of that. And then back office processes, right? Everything they have to do to maintain their IT and their internal operations and their HR and salary payments, all of those are back office processes. So broadly, businesses have to do these three types of things. And these all have to be, again, cognitive and adaptive, right? Driven by AI, for instance. And that agility in all these three layers can be made possible with these exponential technologies that are now at hand. AI, blockchain, automation, IoT, 5G, right? And there's more. This is not necessarily exhaustive. But then how do you operationalize these things, right? Just talking about that is fine. One thing is data is at the core of it, right? More and more, the way you achieve this is you recognize, hey, there's a lot of information in the data that I have in my business for the last 20 years. I've been engaging with customers, but I haven't mined that data to understand what they need and how do I adapt. And I haven't mined the data from the outside world to understand what's going on. So licensed data that you can buy from other vendors, proprietary data that you yourself have, or public data that's out there, right? For example, in agriculture, we're doing a lot of work with data that's publicly available from satellites to help large food companies to understand how crops are growing, what's the health, where do they need to intervene. So data becomes kind of a core, petrol, in a sense, to drive a lot of these things. But then the thing that uses this petrol are these applications, right? The business applications, whether these are HR applications or customer service applications, e-commerce applications. So you might have custom applications that the enterprise have written by themselves, their own Java developers or COBOL developers or .NET developers have written these millions of lines of code. Or they might be legacy applications that have been there for 30 years. Ideally, these are API enabled. You're going to read, if you're not familiar with APIs, you're going to hear about that a lot, I'm sure, day after tomorrow. Cloud native, you're getting to know what cloud native is. So, containers, Kubernetes, functions as a service. So born on the cloud architectures. And of course, digital. And all of this has to run on some IT infrastructure, right? So some computer somewhere has to be running all this to fuel this stack. So these might be public clouds. For example, you might get VMs or container clusters on Google or IBM Cloud somewhere. You have your own data centers. All these companies that I mentioned, they have their own data centers. They have huge server farms of 1,000 machines that's already there running their applications. So those are there and they're going to leverage it. They're not just going to throw it in the dustbin. But on that, can they create a cloud kind of an experience? Just like when you go to an IBM Cloud and it feels like a cloud, you can just ask for a VM. Can you do that from your own data center? That's what private cloud is about. On-premise is your traditional. I have machines, I'm going to use those machines. And then it has to be a secure infrastructure, right? So this is sort of a stack going from the base IT through data applications, operating process to the culture of what a cognitive enterprise has to look like internally to be able to adapt to those changes, right? And the point here is at the bottom you can see is what we are calling as hybrid cloud. And spending so much time on this to help you understand to some extent at least why hybrid cloud is important for all of the large businesses of the world, because they are changing these external change forces. Okay, so a little bit more about hybrid cloud. I thought this is an interesting data point. This is from McKinsey, about a year old report. Very nice big report. I just grabbed a picture from it. It's a nice story. This is a cost story. What I just told you was a business agility story, right? That helps business be competitive and adapt. But there's a cost saving story which is also very compelling. So the way to read this is, today, let's say if you're spending 100 rupees on all of your IT, all of those things I mentioned, your hardware, software, administration, software development, how does different forms of cloud, as you adopt it, help you reduce cost? Of course, these are best case scenarios. It takes maybe a couple of years to get all of your IT moved into that model. but this is what the potential is, right? So the first model is private cloud, where maybe you already have 1,000 machines in your business that you've been using, but not in a cloud way, just installing software and people are using it. But if you install these cloud stacks on it, for example, OpenStack or OpenShift or Kubernetes, and so people start using the same infrastructure with more workloads in a more efficient manner, you can save your IT costs by about 10 to 15%. Excuse me. And there are two models here, right? The IaaS, which is infrastructure as a service. This is essentially what Lakshmi talked about, right? How do you get VMs on demand? You don't have to ask for an actual machine, you ask for the virtual machine. And PaaS is platform as a service, where you might ask for a Kubernetes cluster, or you might ask for an existing database service, right? Or you might ask for an object store service or a messaging service. So you're not asking just for the infrastructure, you're asking for something that performs a function. So of course, as you start asking the things that perform a function, your cost reduces more because you don't have to install that software and have people to manage it for every part of your business. Because it's cloudified in some sense, you can have a small team that manages it all and people just ask for it in demand. Then you go into this private front or backhauling, right? So to understand this, the way to think is, let's say when you log on to your bank's mobile app or a shopping app, right? The first thing, what do? You log on, you log into it. There's a security layer. Where is that security service running? Very likely it's running inside the private network of that company. They probably don't want to put it in the public cloud. Anyway, it was probably made 10 years ago, so it was on their data center. They need to keep it secure so that nobody can hack into it. You don't want people hacking into your login systems, right? We don't want our user IDs to be taken away. So if a company says, okay, I'm going to start moving to cloud, I want to use, Amazon cloud, let's say. They might say, but no, the security front end, I want to keep that inside my network, but all the other back end, product search, product catalog, those things I can move to the public cloud. So that's an example of private front and then backhauling from the public cloud. That also gives you benefits, right? Now you get this IaaS benefit, you get a PaaS benefit, you get down to about 65% of the cost. The second option is public front. That means maybe for some reason you don't need that much security. You move the front end there, maybe because you want to do mobile apps and you want to change the front end very fast. It's easier to do it with cloud. And you keep the back end, your secret data, all of that inside your network. So that's a public front architecture. And then finally, public cloud or clean sheeting is where you take everything just to the public cloud and you don't have any of your own infrastructure to manage. So that of course gives you the most cost savings, but of course there are other considerations like security and compliance. So not everybody will go all the way, they will choose some combination of one of these models, right? That is why hybrid cloud is extremely important for this world. When we say cloud computing, it's a technology, but how big businesses use it is not just, I'll just move everything to one public cloud somewhere. They will carefully choose what stays where. They will use multiple public cloud providers. They will have their own private cloud. They will have their old systems also. And the challenge becomes, when you do that, it's hard to realize the cost savings. Because you need people who understand this, you need people who understand that, and everything takes up extra cost. And hybrid cloud really at its core is about how do you simplify and standardize your application development and management across this hybrid footprint. So you don't need to do different things for every different footprint, right? You can do a common set of things. And that's why these technologies of containers and virtualization and DevOps and all of these things, that's what they're doing. They're standardizing the programming models. Okay. So I find this very insightful, thought worth going through it. So if we agree that hybrid cloud is great, and a company, large company should move from this legacy IT infrastructure to a hybrid cloud, that's where there's a tremendous opportunity for innovation at the intersection of AI, software engineering research, and cloud computing, right? So, just to illustrate this tempo here, that's our big company, right? That's our enterprise. It has a big load on it. It has our business processes that we are doing every day. We are paying people their salaries. We are, doing legal processes. It has its customers, maybe 1 million customers across India who are engaging with it every day. You cannot disrupt the services you're giving them. It has its applications that are running, maybe 1,000 applications for different needs. And it has its employees, right? Maybe there are 10,000 employees who, again, you cannot disrupt or make them unhappy. So you have to carry that whole thing smoothly from the legacy to the hybrid cloud. You need these 3 wheels. And these 3 wheels have to be robust, well designed, and they have to work in sync, right? So it's an illustration, it's a cartoon, but I think it sort of captures the importance of all these 3 coming together, right? So cloud computing research traditionally has been about how do I consolidate resources and make them available on demand. The model has evolved over time, from VMs to containers and function as a service. But increasingly, it is becoming a lot about how do I make application development. It's more about the user than the technology increasingly, right? That's the journey it's on. Artificial intelligence, we all know has gone through a tremendous innovation in this last decade through deep learning, for instance. But it has been heavily focused on, roughly speaking, human language, right? How humans perceive the world. So when we talk about natural language, we talk about English, or how do you interpret natural language? How do you interpret visual things? How do you interpret speech? But we haven't really dug in to see how machines interpret the world, right? What about programs? These million lines of code. What about the logs that are generated from these applications? Software engineering research, for example, program analysis is a big area of research. That's largely been driven by the needs of compiler technology or testing or debugging and things like that, right? But now when we're talking about hybrid cloud, it starts becoming about how do you take an application and make it look like a cloud native application. So all of these 3 things are going to come together in a strong way, and I'll show you some examples of this. So a bit about what does it mean, how do companies think about moving to cloud, right? So I'm just introducing a few concepts here of these themes, practices, and challenge examples. So this is one way IBM thinks about it. I find it useful to look at the world in this way. If you're a company that's thinking about moving to hybrid cloud, you're probably thinking of these 4 themes. Let's start with move. You're thinking, I have these 1,000 applications. Let's take this one that is my e-commerce application. It's running on these 10 machines on WebSphere application server. How do I get it into a cloud native architecture, right? And how much time will it take? Today, it will take somewhere between 1 to 2 years, right? And millions of dollars. So is it worth it? So ideally, you want to reduce that, right? So move is about moving things to the cloud. Advise is about first assessing what all do I have and what should I do first. It's about the strategy. Out of these 1,000 applications, which one should I move to cloud? Which one should I leave here and why? When we talk about build, that's where you talk about building new applications, right? So it's about, okay, I might move some things, but I want to build some new features around it. I want a new mobile interface to it, or maybe I want a completely new machine learning application. And then manage is about once things are there, I need to keep it running. Actually, keeping it running is a huge effort for years and years. When something is slow or your login doesn't work, you complain to customer service, they raise a ticket, and then there's a big team in the back end who's constantly debugging those issues and making sure the application runs. So for an enterprise, there are these 4 themes when they're thinking about journey to cloud: advise, move, build, and manage. And then there are these practices that they have to do on the cloud. I won't go into the details of this, but culture we talked about. Discover, for instance, is about constantly discovering what are the bottlenecks in my IT today? What are the bottlenecks in the way I deploy my applications today? If you don't do that as a regular practice, you're not going to be effective in these themes of advise, move, build, and manage, right? Similarly for the other practices listed there. So I'm going to take just a couple of examples of challenges that enterprises are facing in these themes. One, on the right hand side, is how do I modernize applications to be cloud native? And the other on the left hand side is how do I modernize my IT operations? So there's a particular way that I handle these complaint tickets and resolve issues. That also is transforming. How do I get that? And so let's go through those and get into the technical part of the talk now. So let me explain to you a bit what does a particular IT environment and application look like today, and what does it need to look like, right? So on the left hand side we have the traditional environment. You have some custom application, maybe 500,000 lines of Java code that is your e-commerce application, right? Somebody in your enterprise has written it. There's a team of 50 people who keeps updating it with features and debugging and all of that. But to support that code running, there's a bunch of stuff around it, right? There's a runtime. Maybe there's a WebLogic or a JBoss or a Tomcat that's deployed on a cluster of 10 machines, some of which are in India, some are in Europe, some are in the US, so that you can support a global customer base. But then you have data services, right? Maybe you have large databases where your customer data, your product data is stored, authentication services, right? Actually, those are not data services, those come from the shared services. But you have data services which have data in them and provide some APIs. You have middlewares, for example, a messaging service, right? So, as you get orders, maybe those get sent in as messages to other systems. And you have these shared services like an authentication service that's used by other applications too, right? So that's another application, for instance, that's living alongside it. So when we talk about an application, it's all of these things. It's not just the code. The code is, of course, a big part of it, but there are these other things like runtime and so on that comprises the entire application. And that's running on these gray boxes, right? Oftentimes, these gray boxes are your virtualized resources. Maybe these are VMs, virtualized compute, virtualized storage, and that's hosting this software, which in turn is running on physical resources, maybe your physical servers of different types that you bought over the years, and your physical storage. And it's all interconnected using some network topology, right? So you have firewall rules. This software or this system cannot talk to that system, because maybe you don't want all the different applications in your enterprise to access the password database for your customers, right? So you will block those network connectivity. You might have firewalls with the outside world, again, which are differently configured. So there's a pretty complex network topology around all of this. And this is what ultimately we want to move to a cloud model. So the cloud model is, there's modernized application components. It's good. We don't know what the architecture needs to be. How do I need to change the code? So that's why I have a dashed box. But we know that it has to run on some combination of a container platform. You're going to hear about that today, Kubernetes, let's say. On some virtual machines, right? Because some things just won't run on containers. And I'm probably going to use some software as a service from the cloud, right? Maybe I'm just directly using Watson API from IBM Cloud to do image classification. And then there are going to be these platform services. I'm going to probably need a load balancer because I get so many requests from 10 million clients across the world, especially let's say on Diwali sale day, right? There might be like millions, maybe 1 crore people accessing the portal on the same day to buy that cell phone deal. And so you need to balance that load across different clusters. You will have a virtual private network and SDN and so on. The thing is, how do you go from here to there quickly and at low cost? So you can think of sort of 4 phases in doing this transformation. There's a discovery phase where you first identify, what do I have? What are my programming languages? What is the code? How is the code structured? What are my services that I'm exposing today? What is the topology of the deployment? Which software is over where? And what are the performance guarantees that I'm giving to my user? Okay, I can support 1 million users, coming in 3 hours. So that is some RPS, or I provide some privacy guarantees and so on. Only then you need to know this so that when you redesign it, you don't violate any of these requirements. And you need to know the deployed topology so that you can actually do the transformation. Now the transformation part, I'm dividing into these three phases. One is where you identify what is feasible in the target, right? So Yogesh was just giving me an example of maybe you were maintaining your own email server and you're thinking, okay, I want to move that to the cloud or hand it off to somebody rather than having my own email team. I apologize. So you have so many options, right? You can go to Gmail or Outlook, you can ask somebody to use Lotus Notes or whatever, right? What are your feasible options? And when you're thinking about an application that has all of these components, you have to think about the messaging service, the data services, the runtime. You know, what are my feasible options? If I'm going to IBM Cloud, what do I get there? But from that, what is feasible for me? So you're not really re-engineering yet. You're sort of mapping out your feasible target architecture. The next step is engineering the target, right? Once you've said, okay, these are my feasible options that fit my cost profile and my required, strategy. How do I now change the architecture? Maybe I have a big J2EE application, which is like a monolith that was written in old style J2EE. Now I want to break it up into microservices. I want to put it into containers. So then what should be those microservices? Should I have 50 microservices? Should I have 5? Which parts should be a microservice? Which parts should be together? And then how do I change the code so that it works right and does the same function, but now in a microservices way? So that's the engineering. And then you automate the translation, right? Which is you generate all the deployment artifacts, like your Docker files, yesterday you might have seen, or your deployment descriptors and all of that, so that you automate as much as possible the deployment of it, right? Finally, some team will have to test it, build it in a test environment, and then say, okay, yes, I'm going to put it in the production. So there'll be a manual build step. But we will focus on these three verticals that I mentioned, right? And now let's look at it in terms of the different types of components. You have your custom application, which is the green boxes, the code, right? For that, the feasible architecture is to look at insights of what are the dependencies. If I have, let's say, some COBOL code somewhere, maybe that is not containerizable easily today. If I have a .NET, it's not, I have only one option, which is to move it to .NET Core. If I have J2EE, then maybe I have a couple of options. So it's sort of mapping out your feasible targets from a code perspective. Then you have this AI-assisted application re-engineering. Like I was saying, how do I automatically decompose the code into microservices? How do I automatically, if I'm moving from an old Java runtime to a new one, how do I automatically translate the code? Then let's look at the platform layer, which is all of these stuff around that custom code. I'm looking at containerizability. Do I need GPUs? Am I using GPUs here? Is that containerizable at all or not? I'm looking at, what are the OS and CPU and memory and network artifacts that I have, and what is feasible now when I move it to a cloud architecture. Then the target engineering part is about actually designing and optimizing the target platform design, and then creating those provisioning artifacts, right? So for example, there's a lot of work that's been done on infrastructure as code. So you can actually describe your entire target infrastructure as code without having to wait for somebody to write it up. And then data is the third very important piece, because these data services have huge amount of enterprise data. You can move your code to the cloud. If you don't move your data, you might have latency problems. But then maybe you cannot move the data because it is secret data and you want to keep it inside. Now, which part of the data should you move, which not? It's again a big manual exercise. But can you apply AI techniques to analyze the content of the data and say, hey, I think these are not personal information. These can be moved. These are personal information. You don't need to move it, and associate with the code moves that you're doing. So that's at a very high level. Each of the intersections here by itself can be a research theme, right? And in fact is. So give you a bit more insight into some of these, not all. So we talked about how do you recommend microservices. So let's imagine on the left-hand side you have your deployment. So you have these machines, the code is running there, it's generating logs, maybe you can monitor and profile the JVM, you can collect data. You also have your source artifacts like your source code, your pom.xml, all of these files that describe the application. Maybe you have documentation like your Java docs for the libraries you're using and for your own code. So you want to go from here to some microservices architecture which is integrated into a DevOps CI/CD pipeline. And you're going to hear about that in a couple of days. So one could imagine this microservices extraction capability, right, that addresses some of these challenges. One is business function discovery. Again, back to your e-commerce application, we all use it, right? There is product search as a business capability. There is account management, right? It has all the information about my credit cards and address and all of that. There is order management, all the orders I've placed, what is the tracking, what is the order I placed 6 months ago, returns. So, and then there's customer service. So there are all these business functions. Now, if you have 500,000 lines of code behind it, which parts are doing order management? Now you have to sit down with all the team of 50 coders and spend 1 month to find all those pieces of code. And then think about, okay, if I want to take order management and make it a microservice, that's how I do it. Can there be a module that goes and figures it out? That's an example of where you can combine program analysis and AI to kind of auto figure that out. Data integration, pattern discovery, right? So sometimes you might be using some messaging systems to send data between different applications. Now in the cloud that may not be effective, maybe you want to move to Kafka. So, but you need to find the right integration patterns and the implementation where Kafka may be a good thing. Maybe there are other patterns where it's not a good thing. Again, you cannot sit down with someone and spend months and months. Transaction flow discovery, right? So for example, when you place an order for a shirt on an e-commerce site, there's a lot that goes on. The order is placed, it is recorded in the order management system. Then there's some inventory management in the warehouse that will pick that up and say, do I have it? I need to create a shipment. Then the people who do the shipment pick it up, and that's when you get the tracking. So that transaction spans many applications, e-commerce, inventory management, shipment, all of that. You need to understand those dependencies so that when you redesign, you don't break something. But then again, discovering that is a big challenge. And then modeling goodness of the microservices that you're recommending. There's hardly any work in saying that here's a microservice implementation, how good is it? What does goodness even mean, right? So there are a lot of interesting challenges here. There are a lot of technical approaches around program analysis. NLP, where you just treat the code as text, and you try to understand semantically what it's doing. Repository mining, that has been a big area of research for over a decade now. And graph algorithms that can all be advanced to address these challenges. Here's one example, right? It's a small example. There's this public domain application called Acme. You can just find it on Google. And when you apply some of these techniques without any manual effort, it's sort of showing you the signature of how different parts of the code are interrelated and what function they might be doing, right? And you can see these clusters. Each of these labels is a class. And it's found clusters and cohesion amongst the class functionally. And so an architect can look at this and say, hey, look, maybe those I want to couple into a microservice because it looks like a cohesive business function, right? It's just early results. Let's look at another example. Let's say you have this Java application written in J2E with servlets and all of that. It's running on some old J2E runtime from maybe 10 years ago. It has some Java dependencies, like Guava or struts or whatever, right? There are a lot of these things people use. Now you're thinking this is going to be in the cloud. That Java runtime doesn't work in the cloud anymore. Maybe you want to move to OpenJDK, OpenLiberty, Tomcat, or whatever the cloud provides to you. Also, those old Java dependencies, you need to move them, up version them, right? So a lot of those APIs you are using in the code may not be valid anymore. It's not just one function became another function. Maybe you have to combine 3 different functions for that, or maybe 3 functions became one function. So the challenge is how do you now come up with that re-platform application? So one could imagine that you have a bunch of artifacts that describe the old platform. You have your Java docs for your old runtime, you have Java docs for the dependencies, you have jars that have the actual binaries of those libraries you're using. Similarly for the target, right? Now one could imagine some program analysis techniques and some NLP techniques that analyze these artifacts on the both sides, do semantic and functional differences to auto-detect what has changed in those APIs, and then sort of cross-multiply that with how you're using those APIs in your code, right? To say, okay, then in your code, what are the points that get impacted? And then how do you need to change that code so that it's compliant with the new platform, right? Auto remediation of the code. This can be a very useful thing because it's nuts and bolts stuff that everybody has to do when they move to the cloud. Another example, today you're going to hear a lot about Kubernetes and how container orchestration works. But let's say you decide I'm going to move to this container orchestration framework. But today you might be on any of these older platforms, right? Docker is not even that old, but there are a lot of enterprises that adopted Docker and Docker's own orchestration 3 years, 4 years ago. And now they're looking at these new orchestration platforms as more compelling because they give you a lot of benefits. Similarly, Cloud Foundry was the way people were consuming cloud platform as a service. Again, people are thinking about containers, virtual machines before that, and bare metal before that, and so on. So one can imagine that when you want to move, let's say, a Cloud Foundry application to containers, first you need to discover all of the artifacts you have, because these applications can be very large, right? It's not that they're just 5 modules there. So even knowing what all is there is a big process. You can analyze the code, you can analyze the deployment. Then you need to translate that into a Kubernetes model. So express those constructs in Kubernetes, which you will again hear about today. Once it's there, then you optimize the deployment so it best uses the features of Kubernetes, right? How should my pod design be? What should my ingresses be? What should be my replica sets? What should be my auto-scaling parameters? What should be my cluster size? Which node should I use in my cluster? What network policies should I use? All of that you can optimize because the original deployment was not done for Kubernetes. So it may not be optimal. You need to even project, you are achieving certain level of performance with the old deployment. You were achieving, let's say, 50 users per second being able to use my application. How do you achieve that on the new target? So there's a performance prediction aspect, right? Where you can imagine some machine learning techniques to kind of project that performance on the new target. Because you don't have it running on Kubernetes today. You don't know how it's going to perform. So there's a big, interesting challenge area around doing this translation, doing this modeling and optimization, right? And actually there's work in the open source. I mentioned a couple of projects that are looking at the translation piece, but there's a big research area around the model and optimize. So here's one example of what I mean. Let's say you have this traditional deployment and you're thinking of going to that target architecture. Right now your target architecture has, let's say it has these virtualized resources, what the VMs you have, and then some virtual network that you define to interconnect those VMs, on top of which the red boxes are your Kubernetes containers, right? The containers that you heard about that are hosting different software functionality. And then maybe you have a Kubernetes layer network in Istio or whatever. Now you need to decide all of these configuration variables correctly so that the application performs with the same level of performance as it was. You need to decide your storage capacities and your storage tiers in the virtual hardware. You need to decide in your nodes, how you're going to size the nodes, both in terms of CPU memory, IO speed, placement of the clusters across different geographies. You need to decide your virtualized network topology. You need to decide your container Kubernetes parameters such as your affinity and anti-affinity, your deployment configuration, auto-scaling parameters. And you need to also decide your application network topology. Today, someone would have to do all of this manually. There will be a big architecture team that has experts from all the way from storage, virtualization, to networking, to Kubernetes. And these are very rare skills that cost a lot of money and it takes a lot of time. But if you could have some technology that analyzes your existing deployment, understands how it behaves, takes in the business requirements of, yes, this is the level of performance I have to achieve. My workloads are maybe going to increase 10% in performance every year. I would like to use this cloud and this set of target technologies. And does this optimization, that can be a big benefit, right? That's another interesting research area. So just to tie some of these pieces together, right? How do we envision all of this working together? You have this deployment, you have your source code artifacts. So in the deployment, you get your application logs, you have monitoring of, how much CPU and how your resource usage is over time. Do you have underutilization, overutilization in the morning versus afternoon? You do profiling of your runtimes and you inspect what is deployed. And then on the source code side, you have your code, you have your commit history, and you have your docs. So you do a discovery from all of that to understand what exists and how does it behave. Then the next step becomes to refactor these into microservices. Essentially, the big problem there is you have these business contexts, like I was saying, order placement and product search. How do you map that to different parts of your application topology? And then how do you remediate the code for migration to the cloud platform, and then translate and optimize the deployment architecture on Kubernetes, right? That's how those three things I talked about could tie together. Okay, so let me shift gears after this to the other challenge example that I had mentioned. This was, how do I modernize my applications? The other one is, how do I then modernize how I manage and operate them? So let's step back and look at what one aspect of IT operations is, right, which is incident management. There are many parts to IT ops. Incident management is one we're going to talk about. What is incident management? Something goes wrong, maybe I can't access the database anymore, or it's responding too slowly, my mobile app is not working. So someone will raise a complaint, right? So that's your incident logging. Then there's a team who's going to take that call or take that email or whatever it is, and going to say, okay, should I create a ticket for it, or can it just be? So then there's a ticket creation. It goes into a system like a Jira or something, where a ticket is created, then it needs to be resolved once it's there. Then someone needs to look at it, the details in the ticket, what is it about, and prioritizes it. Is it a high severity incident or low severity incident, right? A low severity might be something that is not critical. Things are still working, but at some point we need to resolve it. And categorizes it. Is it a network issue, most likely, or is it a login issue, or what is it, right? Which kind of team needs to look at it? And then the actual incident resolution happens, where the skilled team is going to read that, go and diagnose the systems and figure out what is the problem. And once it's resolved, you close the incident, right? That's the life cycle at a very high level of an incident today. So we're going to look at a piece of that, right? So to understand places where AI can come in and provide benefits. So particularly if you look at the incident prioritization and incident resolution thing, right? We can think of these four actions that have to be taken. One is your issue detection, right? Which is part of the incident prioritization. So the person who's responsible to assign a priority to it, they might have an AI assistant that analyzes the text, the source of the ticket, and any history of what the system is about. Maybe they know something about how it behaves, and determines the potential impact of the incident, right? So that immediately bootstraps and reduces the work that the person has to do. Second step is this artifacts gathering, right? Where you're sort of saying, okay, what all do I need to know to resolve this incident? Because your application might have a database and a messaging queue and lots of code and network configuration. Which part, what do I need to look at? So you need to gather evidence of course, the ticket that has come in, any other system alerts that were happening at that time, right? monitoring data, metrics and so on that tell you about what might have been happening with the hardware or the software. But you don't want to collect everything out there because it's just too much. So you need to do some localization to understand what is the potential useful information to get. So again, AI can be very useful there to map what the ticket expresses and how does that overlay with the artifacts of the application. Step 3 is the big one. It's the diagnosis. Okay, now we need to figure this out, right? And this is an area of a lot of innovation today in the industry with site reliability engineering, chat ops, where what's happening is, let's say you're on the spot to solve this issue, right? But maybe you're not you know about the networking part, but not the database. And you don't know if the system is responding slowly. Is that because there's a network issue or the database is being overused? So, but you get the ticket. Now you need to figure out who should I talk to about the database. So there's a lot of innovation around using something like Slack and quickly bringing the team together right there so you can do conversations and figure it out, right? So AI can there now figure out, help figure out who needs to be in that by looking at the impact zone and saying, okay, probably you need a database person. It can monitor the conversations that are happening and track the progress and help people understand what is the next best action to take, do root cause analysis and diagnosis, and help that team resolve the issue quickly, right? And then finally, resolution, right? You solve the issue, you summarize the issue, and put the summary back into your ticketing tool and say, yes, solved. So here now AI can learn from what was done to feed into the future. So as an ongoing learning process. Today, this is hardly done in the industry, right? And Slack is just called out because, and it's representative of many chat platforms. But that's a rich source of information that's now emerging with these conversations between experts, from which you can learn how issues are resolved, what goes wrong, who needs to solve what, who is a good problem solver and who's not, right? There's so many use cases that come out of it. So diving a bit into that, Slack conversation mining, right? What can you do there and what benefits can you get? So on the left-hand side, you have, a couple of data sources. Maybe you have a Slack channel where these different experts have been resolving issues and discussing over time. That's a pretty rich corpus of unstructured data, conversation data. Along with that, you also have your historical tickets for which those conversations were happening, the resolution notes and all of that. Now you can imagine, this is perfect AI problem. You can apply AI to understand those conversations, to extract different kinds of knowledge, right? Structural knowledge about what were the entities. Oh yeah, there was something about database login, and that relates to this kind of an issue, right? And reasoning about, okay, once I know these entities and how they interrelate, then what are the typical diagnosis paths that people take? And then sort of derived information about what are the different kinds of issues that are happening, right? Maybe you summarize things. Maybe you find, looks like this is a skill gap area. Every time there's an issue like this, it takes a long time to resolve, right? And so that once you start mining this kind of structured information, you can address so many use cases and give so many benefits, like issue categorization, automating the response, right? So instead of only having people, maybe now you can have an AI that understands enough that can quickly take an action and resolve the problem. Content creation, right? So maybe summarizing and creating a content that goes back into the ticket. Issue action matrix, like when there's an issue, what actions are typically taken. Another example is topology inferencing, right? So let's say you have an incident like I was mentioning that database, I'm not able to log in, it's just waiting on the page. Now what went wrong? Maybe the UI service has a problem. Maybe the network behind that has a problem. Maybe some link broke. Maybe the database in which it's looking up the authentication issue having a problem. And that might be because some other application is doing a lot of authentication. Who knows? Now, if you really need to resolve it, an ideal thing is to first understand the dynamic situational topology of all of this. What's running right now? what requests are being made by which service to which service, say over the last half an hour. And once you have the topological context, then an engineer can say, okay, that this is the trace that I need to follow. I need to check this, and I can resolve this issue, right? But just extracting that dynamic topology is a big problem. It's nowhere there, right? Nobody is curating it every second of the running time of the application. But what you do have is all this digital exhaust data. You have application logs, right? So when someone logs into the database, there's a line that shows up in a log file. When someone, maybe their network logs. There's monitoring data, right, which might tell you about, hey, there's an overutilization happening on the CPU on that machine. There might be your deployment description and Kubernetes logs, for instance, right? So if you can parse all of that, use some AI techniques to extract kind of structured information to create that dynamic topology, that becomes very useful now for you to resolve issues, right? To detect anomalies, to localize faults in that topology. So just zooming out and tying all of this together into some kind of a mega flow, right? Always gives some satisfaction if you can see all the pieces coming together. We talked about modernization first, right? And if I abstract those 3 use cases I talked about, microservices recommendation, code remediation, and Kubernetes deployment optimization, right? Generally, you will see this kind of a pattern where you have that architect, they have some business requirements in their mind that these are the business contexts I have, maybe order management, order placement, product search, and so on. I'm having a problem in product search because people are searching a lot more because now they can search from mobile phones. So they're searching anywhere they can. And that part of my application is not scaling. That's the part I need to scale up. And I need agility because I'm going to start creating WhatsApp interfaces and this and that, right? So next 1 year, I'm going to have a lot of changes, but I want to keep the cost within this much, no matter what I do, right? So they have these business requirements. Plus they have operations requirements. They have requirements that once it's modernized, my team should be able to update features very rapidly with DevOps. It should be easy to manage, right? And resolve these incidents very quickly. Availability should be high, it shouldn't go down. So that's in their mind, and they want to take an application from the legacy traditional architecture to the new architecture with these requirements in their mind. And so you can imagine these steps that have to be done. All these green heads with gears in them are the places where there are big research challenges. So let's say you start with these application artifacts. All of your code, right? The functional code, your deployment descriptors, anything that describes your entire application is code. Your logs that the application is generating, right? It's telling you, that tells you about how it behaves. Monitoring data, for your resources, utilization, and so on. And then docs, right? Java docs or any other documentation you have for different parts of the application. That exists. So there's a big theme of discovery and translation. Whether you're discovering the internal topology of your code, whether you're discovering the deployment architecture, whether you're discovering your network traffic patterns, whatever it is. And then classifying those to understand a topological model. Now this topological model may be at an infrastructure level topology. It may be kind of a component level topology where you have database software components, or it might be within the code. How is your functional topology within the code? What are the patterns? I have queues here, I have data integration there, I have all of that. So this topological model tells you in a structured way how things are tied together and how they work. Then there's this business and operations analysis, right? Where all these requirements that human being has in their mind, performance should be at this level, these are my business functions, they get overlaid on this technical topological model. Oh, these are the parts that are implementing product search, right? And for that part, I need to achieve this much scalability, right? So that's an example of BizOps analysis. This is the part of the code which is very hard to update, when I have bugs, because all the people who have to understand that programming language are gone, right? And so that overlays there, and that's the requirement. So mapping those higher level BizOps requirements to this topologic, again, doing it manually is a big exercise. big research opportunity there. Once you have these BizOps overlays, then there's, then you can optimize and re-engineer all the different artifacts to say, how do I best serve the needs of these business and operational requirements? I understand how they map to my current topology. Where do I need to change what? Whether it's changing the code, whether it's changing the network configuration, whether it's changing my deployment from an old platform to a new Kubernetes compliant platform. So ultimately, you come up with this BizOps optimized target design. Right? Then you of course have to build and test and deploy it, but this sort of captures one consistent flow that goes from the source to a target design. Right? Then when we talk about manage, this topological model starts also becoming very important there. Right? I gave an example. When you talk about management, again you have this data source, your incident corpus, right? And the user here is not that architect. It is someone who's responsible to resolve the issues, maybe a site reliability engineer going forward, right? And so what happens is they get some active incident data, like a ticket comes in. Oh, there's an incident that is active and there's something known about it. With that, some incident analysis has to be done, right? That's an area where AI can come in together with distributed computing to understand this corpus related to the incident. Your logs, your records, historical records, your monitoring data, your old Slack channel conversations that tell you something about how, these incidents, so you can find similar incidents from the past. So then you come up with this, you take the topological model and overlay that incident analysis on it to say, okay, looks like that this incident is related to this part of the topology at this, because that's how things were behaving. So that gives you this incident feature overlay on it. Of course, the SRE may manually analyze it and say, okay, then if this database and these are the components that probably involved, I know how to fix it. Or you might have an intelligent engine that does diagnosis and recommendation for a next best action, what to try next, or who to talk to next, does a root cause analysis to find what is the likely set of problems, and even does a remediation recommendation to say, hey, if you did this, probably it'll get fixed. So then the user consumes it. Maybe they solve the issue, maybe they don't, right? Even if they make incremental advancement that goes back into your active incident data, right, and goes back into this cycle of analysis. If they resolve it, of course, it becomes part of the corpus and the AI continues to learn and keeps helping for downstream incidents. Okay, so that sort of covers the two challenges, high-level challenges that I wanted to cover. This is my last slide. The point here is, there are equally important challenges that we did not cover, and I just wanted to list a few. Of course, we don't have time to go into all of this. Compliance management and live visibility. I talked a bit about regulatory compliance. So as I'm doing these changes, right, I move things to microservices, I move this data to the cloud. Am I still compliant? Am I, these compliance documents are like 200 pages long, English language, which says, nobody should have access to customers' data unless they have this role. Now, after I've done that, how true is it? Who knows, right? Can you discover that in real time? You don't want to be non-compliant even for a week. AI for code vulnerability. As I'm developing code, am I introducing vulnerability patterns into it, right? There are these vulnerability patterns that are easy to hack. They're hard to detect. Now, maybe if I treat code as text and combine that with program analysis, I can detect those upfront right within my IDE. So I don't write vulnerable code to begin with. Continuous optimization of hybrid deployments, right? Once I'm there, and workloads change, the way people consume my things change, can I continuously optimize my deployment? Data modernization, huge topic. So if I'm going to move my data to the cloud, how do I do that? We talked a bit about real-time data moving to Kafka. How do I refactor all of those components? Anomaly detection, both in terms of operations. If something's going wrong in how my system operates, how do I auto-detect it? Or in terms of security threats. Mainframe modernization, I don't know how many of you are familiar with mainframes, but they power a lot of the core business functions. If you swipe a credit card today, more than 90% chance it's going through a mainframe to do that transaction. But mainframe skills are scarce. People want to move pieces of it into a modern architecture. How do you do that? common programming model across hybrid IT environments. If I want to have now describe an application that will have parts in Kubernetes, parts as SaaS, part maybe on a quantum computer in the future, I don't want to write 3 different descriptors. Can I write one program that describes that whole architecture? Machine learning across distributed environments, right? Things like if I have data that's distributed, how do I do machine learning in that distributed setting? Network modernization is a whole other thing, right? Designing networks carefully is a huge skill. And now when you go into these cloud environments, how do you do that properly? And then deployment optimization across edge and centralized clouds, right? Especially when you get into the telco domain or IoT domain, you may have applications that span across, your edge data center, your extreme edge device, and your centralized cloud, right? How do you get that right, and how do you continuously optimize that? Many challenges, right? So in IRL, we are very excited working in this space, and I hope I could transfer some of that excitement to folks here. Thank you. We have 5 minutes. Is there any questions? Yeah, I think if I got you right, the question is, what are the challenges the cloud service provider has in ensuring security and compliance to their tenants?
Because what I heard from you during the talk is like, as from have to focus on the benefits.
Yeah, agreed, 100%. So see, today, oftentimes what these tenants have been doing, they're not yet tenants, let's say. They have their own private infrastructure. They keep it private. So first of all, it's very hard for anybody from the outside to get into it. So it gives them flexibility in how they manage the data inside, because it's sort of a private space. Maybe they don't have, they take a lot of care, but putting it in a public environment needs even more care, right? So that's why there is some hesitation in, say, financial companies and government institutions to just move stuff there. So you're completely right. Now the cloud service providers want them to move to their clouds, right? So they have to assure these tenants that they can comply with all of the regulatory requirements, security requirements that the tenants have to comply with, right? So for example, IBM recently announced that we are going to create the first financial services compliant cloud with Bank of America, right? So that means now IBM takes up a lot of responsibility to ensure vertically top down that infrastructure, the IaaS, the PaaS is compliant with how a bank might have done it with their own infrastructure, right? So that goes all the way, of course, from networking security, data security, to physical security, right? So if those machines have to be in a separate data center with a lock and access only for 3 people who are allowed to access that, separate from some other data center, right? So it becomes technology challenges and also operational challenges. But at a foundational basis, it's not that different from what would have been done in the tenant's own data center, right? But there's a big opportunity to innovate, because if the cloud service provider is now having multiple tenants who all have common requirements, that economies of scale, they can use automation, they can use AI to kind of auto-detect deviations and anomalies, and they can invest in innovation a lot more than perhaps a single tenant would have done in their own data center, just like any other cloud paradigm, right?
There has to be, what I understood, they have to invest this area.
Of course, definitely. As you can see, IBM is investing a lot, but definitely yes.
Okay, so take it offline then.
Yeah, maybe let's have a discussion. I think that'll be more interesting for fault localization. Yeah. Yeah, it's a long one.
Thanks a lot again. Let's thank Amith again.
Thank you.